All right, in this lesson we're going to be talking about graphing inequalities. So when we graph an inequality, what you want to do first is graph the basic function, and note that if you have a greater than or equal to or a less than or equal to, you make a solid line, and if you have just a greater than or a less than, it will be a dotted line. Now, to determine which side you shade, the strategy that always works, the traditional strategy, is to test a point on either side, substitute that point into the equation, and if it works, you shade that side. If the point does not work, you shade the other side. I have another strategy that I like to use, but it only works if you have first solved for y. And what you do is you put your pencil on the y-intercept then, and you shade above if y is greater than, and you shade below if y is less than. And I will show you that as we go here. So here we have y is greater than 3x minus 1. So it is a linear function, so we will graph that. The y-intercept would be -1, and the slope is in front of the x, or that's 3. So we go up 3 over 1. Up 3 over 1. We'll graph a few points here. And then we'll go down 3, back 1, down 3, back 1. So now we have some points, and since this is greater than, it's not equal, it's greater, so we will make a dotted line then. So now, since this is solved for y, it only works to use this strategy when it's solved for y. We put our pencil on the y-intercept, so where this crosses the y-axis, and it says y is greater. Well, if you look at the y-axis, the y's get smaller this direction, the y's increase this direction, and so we're going to shade on this half. Now, the other way you could do this to determine which side you shade on is you can pick a point. Like, let's say we pick this point right here. This would be over 1 up 1, 2, 3, 4, 5, 6. So we pick the point 1, 6. We can substitute that in for the x and the y. So 6 is greater than, I'll put a little question mark there because we have to see 3 times 1 minus 1. 6 is greater than 3 minus 1 is 2. That is true. So all the points on this side of the graph, every single coordinate here would work when you substitute it into this graph. Let's just test a point on the other side to see what would happen. Let's substitute in 4, 3. So if we substitute in 4, 3, we have the y is greater than 3x minus 1. So 3 is greater than 3 times 4 minus 1. So 3 times 4 is 12 minus 1 is 11. 3 is not greater than 11. So this point over here did not work. So let's do another one real quick here. The y-intercept is at -1. Your slope is 3 over 1 again. And this time it says y is less than or equal to. So since it's equal to, also we're going to make a solid line. And now to decide where we graph, we put our pen on the y-intercept and it says y is less than. Well, the y's are less than going down this axis. So this will be the side that we shade. The next one, it says what is the graph of each inequality? So again, we'll graph this function. The y-intercept is 1. Oops, let me go back here. My pen went a little crazy there. So the y-intercept is at 1, and the slope is -2. So down 2 over 1, down 2 over 1, down 2 over 1, or we could go up 2, back. And there it says it's equal to, greater than or equal to. So since we have an equal to there, it will be a solid line. And we put our pen on the y-intercept and it says y is greater. So y's are greater this direction up the y-axis. So this will be the side we shade. Next equation, graph the function. Y-intercept is 1. Slope is -2. So down 2 over 1, down 2 over 1. Or we can go up 2, back 1. And this time it just says y is less than. It doesn't say y is less than or equal to. It's just less than. So this will be a dotted line. And less than, the y's, if you look at the axis, this way they would be going increasing, this way they would be decreasing. So it's going to be this direction, and there we go. All right, so when you have an x is greater than -2, so remember when we have an x equals something like this, it is a vertical line. I always think an x looks like two little v's stuck together here at the vertex. So x's are vertical lines. So to graph that, you go to -2 on the x-axis, and it says it's not equal to. This actually just says greater. So this will be a vertical line, but it will be a dotted one. And here we're going to put our pen on the x-intercept, and it says x is greater. So which way would the x's be greater? Going this direction. So every value on this side of the line will work here. Now let's just pick a few points. Like let's say you picked this point right here. That would be 1, 2, 3, 4 over 4 up to. The x value there is 4, and that is greater than -2. Y, I always think that Y's are kind of like upside down H's for horizontal. So Y equals, or Y equations, when it's just a plain old Y, that is going to be a horizontal line. So what we do is on the Y axis, we're going to go to -2, and it says greater than, so again it's not equal, so this will be a dotted line. And then put your pen on the y-intercept. Y is greater this way, so we're going to graph everything here. This is a y greater than or equal to 0. So y is a horizontal. So on the y-axis, we go to 0, and we're going to draw a horizontal solid line because it says equal. And y is also greater, so we're going to shade everything above. And the last one, x, again, remember, that would be a vertical line. So on the x-axis, we go to 0, and we will make a solid vertical line through 0. And it says x is less than or equal to, so it's going to be everything on this side. All right, real quick, we have a word problem to do. It says, the map shows the number of tickets needed for small or large rides at the fair. You do not want to spend more than $15 on tickets. How many small or large rides can you ride? Well, let's see. Tickets are $0.25 a piece. Large rides are 5 tickets. So the large rides, we'll call those Y. And how much do those cost? 5 times 25 cents each. Those are $1.25 each. And the x-axis has the small rides. And so the small rides, those are 3 tickets each, so they're 75 cents each. So we can make an equation. It would be 75 cents times the number of small rides we go on, plus $1.25 times the number of large rides. That amount has to be, let's see, you do not want to spend more than 15. It has to be less than or equal to 15. So that would be our equation. So now if we graph that equation, we have some different methods that we could use. We could do the intercept method of graphing the line. What I told you before, though, is that if we solve for y, we know which side to shade it on. We don't have to test the point. So we have options here how we want to do that. Let me grab my calculator here. So we would subtract 0.75x from both sides. So you have 125y is less than or equal to negative 0.75x plus 15. And then we divide every term by 125 to simplify that. So y then is less than or equal to 0.75 divided by 125. It would be 0.6x, and that's a negative because a negative is divided by a positive. And then 15 divided by 125 is 12. So the y-intercept's at 12, and the slope is 6/10. So we're going down 6 over 10. So the line is graphed here. And then to shade it, y is less than the y-intercept, so this side is shaded. So now what we've done here with this problem is we've shaded everything that will work, all the combinations where we would be spending less than 15. So for example, 4, 4 would be would work there. If we substitute in 4 for the x and 4 for the y, we'd have 0.75 times 4 plus 1.25 times 4. And let's just see what that is. 0.75 times 4 plus 1.25 times 4 would give us 8, and 8 is less than or equal to 15. It's less than 15. So this value works. So any of these combinations, so if we went on 0 of the small rides and 10 of the large rides, well, 10 of the large rides would bring us to 1250, which is less than 15. So this gives us all of the different combinations of rides that we could go on. All right, the last thing we're going to do is graph an absolute value function. And so first, it's an absolute value inequality function, I should say. We will plot the 0.14. And the slope on the right side is 2. So we're going to go up 2 over 1, up 2 over 1. Go back to the vertex, go up 2, back 1, reflect it over an axis of symmetry, and it says it's greater than or equal to. Now, if it was only greater, it would be a dotted line, but it's also equal to. So graph the function, and now go back to my little strategy. We have the y solved for, we've solved for y, so put your pen on the y-intercept, and y is greater than, so it's going to be everything basically inside of the V. If y was less than, we would shade all of this out around it. Now here's another one. This time y is not solved for, it's not solved for y yet, so we have to first get it into that form. So we have minus y is less than the absolute value of x plus 2, and then minus 1. And we don't want minus 1, or excuse me, minus y, so we divide everything by negative 1. So y then, since we divided by a negative, we have to flip the arrow. It would be all of this divided by a negative 1, so that's a negative 1 times the absolute value of x plus 2. Nothing affects the inside of absolute value. So remember, there's like a 1 on the outside of that, so 1 divided by negative 1 is a negative 1. And then at the end, negative 1 divided by negative 1 is a positive 2. So we're going to go over 2, up 1. To plot the vertex, and the slope is negative 1. So we're going to go down 1, over 1. Go back to the vertex, go down 1, back 1. And it says y is greater than, so it's not equal, so we just make a dotted line. Put your pencil on the y-intercept, and it says y is greater, which is this direction. So we're going to shade all around the outside of that thing. So all the values up here, all of these coordinates in the shaded area will work when we substitute that back in. And I guess I said before it was the last thing, but we do have one more thing to do. We have to write inequalities. So this is absolute value, so we need your HK. So here we're going to go over 3 and down 2. And the slope on the right side would be, we'll pick a couple points here. We're going up 1, over 1. It's A. A equals 1. So y, and if we put our pen on the y-intercept, we are shading above, and it's a dotted line. So we say y is greater than A, which is 1, and then x minus h, which is a 3, plus k, which is a negative 2. And there's your equation. The last one, this graph is counting by 2, so we're going to go back 4, up 3. And the slope here, we go down 1, over 1. So it's a negative 1. And so y-intercept, I'm looking here, it's not, this line is not solid, so it's not an equal to, but it is shaded above, so it's greater. So y is greater than negative 1 times x minus a minus 4 plus 3. And that is the graph of that. And that's it for this lesson. Thanks for listening.